Hello everyone. Today we are going to discuss about DC motor. So the syllabus which includes DC motor, construction, principle of operation, types of DC motor, torque equation, characteristics and applications of DC motor, and starters used for DC motors, 2-point starter, 3-point starter, and speed control method of DC motor. Under the category we are going to see about armature and field control method. Electrical motor. A electric motor is an electrical machine that converts electrical energy into mechanical energy. Most electric motors operate through an interaction between the motor's magnetic field and electric current in a wire winding to generate a force in the form of torque applied on the motor shaft. Here you can see the three diagrams. Here one is a pick and place robot mentioned in the diagram, and here we have wet grinder, and another one is the ceiling fan. So these are all the examples of electrical motor. Electrical generator. How motor and generator going to get vary. So mechanical energy is converted to electrical energy is known as the generator, where in case of motor, electrical energy is converted into a mechanical energy. So here they mentioned the various power plant. Here they mentioned the various power plant. First one, hydropower plant. There is upper reservoir and lower reservoir. Both are connected with the help of the penstock pipeline. If the upper reservoir gate valve is open, the water is flowing from the upper reservoir to the lower reservoir. So based on this force, the turbine starts to rotate. If the turbine rotate means it's going to generate the electricity. The shaft is attached to the generator, so it's going to start the electricity. This electricity can be transmitted with the help of the transmission line, and it can be sent to the different types of substation. And another diagram we can see here. Next one is a coal power plant. Another one is that wind power plant. Next, difference between the motor and generator. The motor converts electric energy into the mechanical energy, whereas generator does the opposite. Electricity used to in the motor, but the generator produces the electricity. The current is to be supplied to the armature winding in case of motor, and in generator current is produced in the armature winding. So this is a major important difference between motor and generator. So types of motor. Electrical motors are classified into two categories. One is that AC motor and another one is the DC motor. AC motors, linear motor, synchronous motor and induction motor. Synchronous motors are called reluctance hysteresis, and induction motor may be a single phase induction motor or three phase induction motor. Next, coming to the point of DC motor. The DC motor consists of self-excited DC motor, separately excited DC motor. Self-excited motor classified into three categories. One is series DC motor, compound DC motor, shunt DC motor. Again the compound DC motor classified into two categories. One is the long shunt DC motor, short shunt DC motor. So construction of a DC motor. A DC machine consists of stator as well as the rotor. We know that stator is a stationary part which consists of the field winding. It is also called as the field system, where in case of rotor is a rotating part in which armature windings are placed. So it is also called armature system. So this is a cross-sectional diagram of a DC motor. In this diagram we can see the field coils, armature coils, field supply voltage and carbon brushes. So this is a cross-sectional view of your DC motor. Construction wise, we have a yoke. Another name of yoke is called the frame. The main function of the yoke is the machine is to offer a mechanical support for poles and protects the entire machine from the moisture, dust, etc. In order to prevent this kind of thing, we can improve the efficiency of the motor. So yoke plays a major role to protect from the atmosphere, moisture, dust and etc. Material used for the yoke: cast iron, cast steel. Otherwise we can also use rolled steel material. So these are all the material used for the yoke. So this is our structure of the yoke and frame. It consists of the terminal box, lift eye, which is used for pick and place, and here we have a frame and we have a feet. The feet is connected with the help of bolt in order to be stable operation. Next we have a pole cores and pole shoes. The field magnet consists of pole core as well as the pole shoes. The pole shoes serves two purposes. They are separated, they are spread out the flux in the air gap, and also being a larger cross section reduce the reluctance of the magnetic path. The support of the existing coils. So this is a diagram of laminated pole core and laminated pole shoes. So this is a field coil. So this field coil consists of both the pole core as well as the pole shoe. Next we are going to see about the important thing is the field system. The function of the field system is to produce a uniform magnetic field within which the armature rotates. Field coils are mounted on the poles and carry the DC exciting current. The field coils are connected in such a way that adjacent poles have opposite polarity. The magnetic motive forces developed by the field coils produces a magnetic flux that passes through the pole pieces, the air gap, armature and the frame. Here the practical DC machines have the air gap range varies from 0.5 mm to 1 mm. So this is the range we have to maintain for the air gap 0.5 mm to 1.5 mm. Next, this is a diagram of we have seen the terminal box in the yoke system also. This terminal box used to produce the power supply for both the field coils as well as the armature coils, and we have a commutator, brushes, and we have a yoke system for the protection purpose of inside the coils from the external disturbances of moisture as well as dust, etc. And field system, armature coil, armature conductors. Construction, armature core and lamination. The armature core is keyed to the machine shaft and rotates between the field poles. It consists of slotted soft iron laminations, thickness between the range 0.4 to 0.6 mm. The laminations are individually coated with a thin insulating film so that they do not come in an electrical contact with each other. The purpose of laminating the core is to reduce the eddy current loss. Thinner the lamination, greater the resistance offered to the induced EMF, smaller the current, and hence lesser the I square R loss, which means that copper loss in the core. So this is a armature core and armature winding. The slots of the armature core hold insulated conductor that are connected in a suitable manner. This is known as the armature winding. The working EMF is induced in the armature winding. The armature conductors are connected in series parallel arrangement. The conductors being connected in series so as to increase the voltage, and in parallel path as to increase the current. Depending upon the manner in which the armature conductor is connected to the commutator segments, there are two types of armature windings in the DC machine. They are lap winding and wave winding. Here you can see the diagram of the commutator. So commutator is a mechanical rectifier which converts the alternating voltage generated in the armature winding into a direct voltage across the brushes. The commutator is made up of copper segments insulated from each other by mica sheets and mounted on the shaft of the machine. The armature conductors are soldered to the commutator segments in a suitable manner to give rise the armature winding. So you can see here how the AC voltages are converted into a DC manner. For that purpose only we are using commutator in the DC motor. The working principle of the DC motor. We know the basic principle of the DC motor. When a current carrying conductor is placed in an external magnetic field, the conductor experiences a force perpendicular to both the field and the direction of the current flow as per the Fleming left hand rule, and its magnitude decides the direction of the force. You can see the diagram here. We have Fleming left hand rule. The thumb indicates the motion and the index finger indicates the magnetic field and middle finger indicates the direction of the current. When the armature windings are connected to a DC supply, A electric current setups in the winding. A magnetic field may be provided by the field winding by using a permanent magnet. In this case, current carrying armature conductor experiences a force due to the magnetic field. Commutators made up segmented to achieve unidirectional torque. Otherwise, the direction of the force would have reversed every time when the direction of the movement of conductor is reversed in the magnetic field. When the back EMF, one of the important topic, when the armature winding of a DC motor rotates in the magnetic field produced by the field winding, it cuts the magnetic fields. An EMF is induced in the armature winding according to the Faraday's law of electromagnetic induction. But as per the Lenz's law, the induced EMF acts in the opposite direction to the armature supply voltage. Therefore, this EMF is known as the back EMF. It is denoted by E suffix B. So this is a formula for back EMF. We have EB is equal to P phi NZ by 60 A volt.